What if I told you that some of the most beautiful ideas in mathematics live in a world where motion, limits, and infinity are all constantly colliding? Real analysis is that world. It is the branch of math that asks, what really happens when we zoom in forever? When does a process settle down? When can we trust our intuition about curves, functions, and infinite sums? And today, I want to show you 5 real analysis ideas that are not just important, but genuinely fascinating. First up, limits. A limit is the mathematical way of describing what a function is getting closer and closer to, even if it never actually reaches that value. That sounds simple, but it is powerful. Limits are the backbone of calculus, and they are what let us define derivatives and integrals with precision instead of hand-waving. Why is this useful? Because in the real world, you often care about behavior near a point, not just a point. For example, in physics, velocity is not just distance divided by time over a long period. It is the instantaneous rate of change, and limits make that exact. Next is continuity. A function is continuous if small changes in input cause small changes in output. In other words, no sudden jumps, no weird breaks. That might seem obvious, but continuity is one of the most important properties in analysis. It is what makes functions predictable, and it powers huge theorems like the intermediate value theorem, which says that if a continuous function goes from negative to positive, it must cross zero somewhere in between. That is incredibly useful in practice. Engineers use this kind of logic in root-finding algorithms, where computers approximate solutions to equations by searching through continuous behavior. Now let us talk about sequences and series. A sequence is just a list of numbers. A series is what you get when you add them up. Here is the fascinating part: infinite sums can actually converge to a finite answer. That means you can add endlessly many terms and still get something meaningful. For example, geometric series show up everywhere, from finance to signal processing. If you understand convergence, you can predict whether a calculation stabilizes or blows up. That matters in everything from error analysis to algorithms. This is one of the deepest ideas in math. Infinity, when handled carefully, can produce exact results. This one is a favorite of many mathematicians: compactness. It is a technical idea, but here is the intuition. Compact sets are infinite spaces that behave in a surprisingly controlled, almost finite way. Why should you care? Because compactness gives you powerful guarantees. For example, continuous functions on compact sets always attain a maximum and a minimum. So if you are optimizing something, say minimizing cost, maximizing efficiency, or finding the best design, compactness tells you a solution actually exists. That is a huge deal in applied math and optimization. Without compactness, you might search forever and never know whether the best answer is even there. Finally, uniform convergence. This is one of those ideas that separates looks like it works from actually works everywhere. A sequence of functions may converge point by point, but that does not always mean the convergence behaves nicely overall. Uniform convergence means the approximation becomes good at the same rate across the entire domain. That matters because it lets you safely swap limits with other operations like integration and differentiation. In other words, it protects your calculations from subtle mistakes. This is useful in numerical methods, Fourier analysis, and anywhere approximations are used to model reality. If you want your math to hold up under pressure, uniform convergence is one of the tools that keeps it honest. So those are 5 real analysis concepts that reveal something amazing. Behind the abstract language, there is a deep structure to change, approximation, and infinity. Limits tell us how things approach. Continuity tells us when behavior stays steady. Sequences and series show how infinity can still be controlled. Compactness tells us when solutions must exist. And uniform convergence tells us when approximations are truly reliable, if you love math. Real analysis is where intuition gets sharpened into something rigorous and beautiful. And once you start seeing these ideas, you notice them everywhere. The 5 most fascinating real analysis concepts every math lover should know is just one small part of real analysis. If you are interested, our full free real analysis course is linked in the description.